2 modeling expressions. So when we're modeling expressions, we want to look at terms, coefficients, and constants. Your terms are each part of the expression. Your coefficients are the numbers in front of those variables. Remember, the variables are your letters. And your constants are just the number by itself, the ones that don't have a letter attached to them. So if we look at example 1, we're identifying the terms and the coefficients in 8p plus 2q plus 7r. So our terms are the 8p, the 2q, and the 7r. Now those coefficients are those numbers in front of the variables. So those are the 8, the 2, and the 7. Remember, a constant is a term that does not have a variable attached to it. So if we look at example B, we're identifying the terms, the coefficients, and the constants in 18 minus 2x minus 4y. So you want to remember when you're doing this, you're keeping the sign in front of the term with the term. So if we look at terms, we have 18, negative 2x, and negative 4y. Your coefficients are that negative 2 and that negative 4, and your constant is just the 18. If we look at example C, we have 2x plus 3y minus 4z plus 10. So those terms are the 2x, the 3y, the negative 4z, and the 10. Your coefficients are the numbers in the front of the letters with their sign in front. So it's a 2, a 3, and a negative 4. Your constants are just the number without the letter. So that's the only one there is 10. If we look at the next example, it tells us that tickets to an amusement park are $60 for adults and $30 for children. If A is the number for adults and C is the number for children, then the cost for A adults and C children is 60A plus 30C. What are the terms of the expression? So we have a 60A and a 30C. What are the factors of 60A? Well, the factors of 60A are what make up that number. So it's just the 60 and the A. What are the factors of 30C for F? Well, that's the 30 and the C. They want to know what the coefficients of the expression are, so the numbers in front of the variables, so that's the 60 and the 30. And then it tells us to interpret the meaning of the two terms of the expression. Well, 60A is the cost for adults. And the 30C is the cost for children. If we look at our next examples, for example 1A, it tells us that to interpret the algebraic expression corresponding to the given context. So for A, it tells us that Curtis is buying supplies for his school. He buys P packages of crayons at $1.49 per package and Q packages of markers for $3.49 per package. It asks, what does the expression 1.49P plus 3.49Q represent? Well, the total cost of P packages and Q markers is what that expression represents. So this is the total cost of P packs of crayons and Q packs of markers. For B, it tells us that Jill is buying inkjet paper and laserjet paper for her business. She buys 8 more packages of inkjet paper than P packages of laserjet paper. Inkjet paper costs $6.95 per package, and laserjet paper costs $8 per package. What does the expression 8P plus 6.95 times P plus 8 represent? Well, this expression represents the total cost of packages of inkjet and laserjet paper that Jill will buy. So this is the total cost of both inkjet and laserjet paper that Joe will buy. Oops. If we look at the next two examples, for 3, it says that George is buying watermelons and pineapples to make fruit salad. He buys W watermelons at $4.49 each and P pineapples at $5 each. What does the expression 4.49W plus 5P represent? So this expression represents that 4.49W plus 5P is the total cost of watermelons, and pineapples. That George will buy. For 4, it tells us that Sandy buys 5 fewer packages of pencils than P packages of pens. Pencils cost $2.25 per package, and pens cost $3 per package. What does the expression 3P plus 2.25 times P minus 5 represent? So we have that expression 3P plus 2.25 times P minus 5. This actually represents the total cost of pens and pencils that Sandy will buy. If we look at the next set of examples, we're comparing algebraic expressions now. So we're looking for equivalent expressions. For example, 2a, it tells us that x plus y and 2x are those equivalent expressions. We're comparing the expressions and telling which of the given pair is greater. So the expression 2x is greater because if you plug in values for the x and the y, let's say x is 1 and y is 2, it tells you that x is greater than y. So if x is 2 and y is 1, if you plug it into the x plus y, you have 2 plus 1 is 3, and then 2 times x, or 2 times 2, is 4. So the 2x would be greater. For b, same thing. It tells you that x is greater than y. So we have that x over y, so 2 over 1 and 1 over 2. What's greater? The x over y. For 5 and 6, we're doing the same thing. It tells you that x is greater than y and y is greater than 0. So if y is greater than 0, that can be a 1. So y can equal 1. And if x is greater than y, x can equal 2. So if we plug these values in, we would have 2 over 2 plus 1. And then we would have 2 plus 1 over 2. So 2 plus 2, 2 over 3, and 3 over 2. Well, 3 over 2 is greater than 2 over 3, so the x plus y over x would be greater. For 6, we're doing the same thing. So x is 2, y is 1. So 2 times 2 plus 1 and 2 plus 1 squared. So 2 plus 1 is 3, so 2 times 3 is 6, and 2 plus 1 again is 3, and 3 squared is 9. So the x plus y squared is greater. We want to remember, so this table here gives us keywords to look for, or expressions to look for when we're dealing with addition, subtraction, multiplication, and division. So you're now going to be forming these expressions with the wording that they're giving you. So if we look at the next example, for example 3a, we're writing an expression to model the given context and giving our answer in simplest form. So if we can combine like terms, we have to do that with these. So for A, it says the price of an item plus 6% sales tax. So the price of an item would be X, and the plus 6% sales tax would be the 0.06. Remember, when you're dealing with tax, you got to turn it into a decimal, times what that price of the item was. So we're doing the total of these. It's going to be a plus, so X plus 0.06x. Remember, the coefficient of that x by itself is 1. And if we go to add those, we're going to have 1.06x. For B, it says the price of a car. Well, we don't know what that is, so that's going to be x plus the 0.085 sales tax added on to that car. So that's going to be 0.085 times x. So if we give ourselves an expression with this, we're going to have x plus 0.085x. The coefficient of that x by itself is 1. If we go to add these, it's going to be 1.085x. If we look at those extra practice problems, we're translating each phrase into a variable expression. So 8 times a number, for example 1, would be just 8 times a number, or 8x, or 8n, whatever variable you choose to use. For 2, it says the product of 3 and a number. Product means multiplication, so that's 3 times a number, so 3n or 3x, totally up to you again. For example 3, we have 5 more than a number, so that's a number plus 5. Remember that more than means that you're adding 5 to a number, so it's going to come after the variable for that number. For 4, we have 1/4 of a number. Of means multiplication, so that's just 1/4 of a number, or x over 4, same thing. So for example 5, a number decreased by 4. A number decreased, you're taking 4 away from a number, so that's x minus 4, n minus 4. For 6, a number divided by 5, so that would be x divided by 5, or x over 5. And then for 7, we have 9 less than half a number. 9 less than means that we're taking 9 away from, and half a number means 1/2 times the number. So if we're taking 9 away from that, it's going to have to be 1/2 n minus 9. We can also do this as 1 or n over 2 minus 9. They mean the same thing. For 8, we have 9 more than twice a number. 9 more than means that we're adding 9 to a number. Twice a number means 2 times n. So this is going to be 2n plus 9. I'm going to do that a little bit thinner. There we go.